This is going to be my first video on circular functions. Now, I've been talking about a lot of other stuff, from radians to wrapping functions. Now we're going to talk about circular functions. Alright. Now, when you talk about circular functions, what they're wanting you to do is to do some number conversions. You're sitting there going, oh no, this is going to be horrible. No, not really. Okay. We have a circle right here, and we have a point. Now, this point is a point that actually connects this circle to what is called a tangent line. Do you remember what I talked about in one of my previous trig videos about tangent lines? All right, this point connects this circle to an invisible tangent line, which you can't see, but it's here. Okay? All right. Now, we want to know the coordinates of that particular point, because it's at that particular point that the tangent line will connect with the circle. Okay. Now, well, you say, well, we'll just use the Cartesian coordinate system, and we'll just put a little number for x and a little number for y. Well, that'll work. Except this is a unit circle. So what's so special about a unit circle? Well, do you remember when I talked about in a few videos ago that what you had in the line of a unit circle is that the radius was going to be one of some unit? Okay? And I told you the unit it doesn't matter whether you're using miles, millimeters, any length you want to use, as long as that unit is 1, it counts. So this is why it's called a unit circle. Alright? Now, so basically we find coordinates. Now the thing is, what we're going to do is we're going to change the coordinates here into something called radians. And there's only one way to do that. Okay, so we're going to change these coordinates into radians. Now, we're not going to do that in this video, but I'm going to show you eventually how to change those coordinates into radians. Now, how do you find the coordinates of x? Alright. Do you remember the Pythagorean Theorem? If you don't, you need to go back to Euclid Book 1, proposition number 47, learn that, and come back here. Okay, now then, what we're going to do is we're going to convert the x coordinate here into the cosine of s. Now, what is s? Okay, what's this s? Well, s is the arc that is formed between this point and this point. Between these 2 points is a length called s. Okay. And we're going to convert the x coordinate of the beginning of s into something called the cosine. How do we do this? Okay. If we draw a Pythagorean triangle like this here, then the x coordinate of this point is exactly the same as the x coordinate of this point. The y is different, but the x is the same. Okay? So, if we were to find this x coordinate, we could say adjacent over hypotenuse. Well, the ratio of adjacent over hypotenuse, in other words, you divide the adjacent by the hypotenuse, that's going to come up with the cosine. So we're going to change the x coordinate to the cosine, because that'll give you the x coordinate of this point. Alright? Likewise, what about the y coordinate here? Alright, y coordinate's here, it's also down here. Alright, now here's how that one's going to work. The y coordinate is the opposite side over the hypotenuse. Well, as we know, the opposite side over the hypotenuse is sine. Okay, that's the sine ratio. So, basically what we've done here is we have found the cosine and sine of x and y. So we're going to change x and y, these coordinates right here, into the cosine of s and the sine of s. That's all we're doing. And that's because of this ratio. Alright? And so therefore, you're able to do this. So, we have the length of S. We're going to change the x and y coordinates at the beginning of S to cosine of S and sine of S, and it's because this adjacent and opposite. If you get confused about any of this, leave a comment down here below, and I'll further explain. But in the meantime, this is Ted the Speed Learner signing off. I will tell you more in a future video, so stay tuned.